Before we present storage lifecycle management for day 0, day 1, and day 2 operations, I would like to take this opportunity to discuss more importantly some use cases and reference designs you may want to consider when setting up storage pools within SuperCloud Composer. SCC offers two types of storage pool frameworks for storage architects. One type is iSCSI storage, and the other type is NVMe over Fabric for both RDMA Rocky traffic and PCIe switching traffic. Another use case that is gaining somewhat popularity today is direct storage or direct attached storage for JBOF rulers across interconnected PCIe switches. Of course, some of the early implementations of DAS is when a head node was directly connected to a JBOF. Although still supported, it's losing popularity because of its lack of scalability. In Figure 1, we represent NVMe initiators and targets and how a storage architect would carve up NVMe drives into storage pools for end users to be allocated certain chunks of an NVMe shared flash drive. There are really three key elements required for NVMe over Fabric supported configurations. They are discovery host, initiators, and targets. Although the Figure 1 leaves out the depiction of discovery host in its illustration, it was purposely left out so it would not create any kind of confusion for the viewer. We tried to provide the viewer a simplistic view of how storage volumes would be represented to an end user. So what is an NVMe initiator? Simply, NVMe initiators ask discovery nodes what NVMe volumes are available through SCC's storage pool. NVMe target systems advertise their NVMe drives to their discovery hosts. NVMe targets can have direct attached SAN through either backbone storage appliances, back-end compute systems, or back-end JBOF rulers discovered across some kind of fabric architecture. In the YouTube video presented by SNE, they do a very good job of presenting discovery automation for NVMe IP-based SANs. I highly recommend you view it for some clarity. When provisioning NVMe over Fabric or iSCSI SANs for the first time, be sure to take advantage of SCC's streamlined deployment infrastructure service, providing the storage admin an easy role-based setup. When deploying role-based setup for initiators, NVMe discovery controllers, and targets, one can select a predefined seed from an automated answer file to streamline an administrator's deployment. You can review the section on storage for detailed configuration, support, and setup. So what's different in Figure 1 versus Figure 2? If you look closely between Figure 1 and Figure 2, you will see the interconnect that connects both host initiators and host targets are different. Figure 1 shows hosts, targets, and discovery controllers connected through an Ethernet switch fabric, relying on special RDMA Rocky parameters to be configured for the Tor storage switch. Also, each host participating in the fabric will require RDMA Rocky capable NICs that are interconnected to the Ethernet switch. In Figure 1's depiction of its reference design, you may want to think about implementing Supermicro's golden SKUs of DC Cloud, Hyper, and Big Twin, or perhaps several storage appliances that have a CPU embedded processor to process NVMe over Fabric payload traffic through its TCP/IP protocol. Certain Supermicro JBOF designs lack capable RDMA Rocky NICs to broadcast their capable ID assignment across an Ethernet-based architecture, so would not be an ideal candidate for Figure 1's reference design. In Figure 2, Back-end JBOFs are interconnected to a PCIe switch architecture, allowing cable IDs to be known to PCIe switch ports. When connected, their cable IDs can be mapped to endpoints by discovery hosts and targets, thus advertising available volumes to SuperCloud Composer's storage pool. When an initiator discovers an NVMe endpoint, its Linux kernel is free to mount it and present it to Linux's file system. In Figure 3, we illustrate an iSCSI storage framework to support a boot from SAN operation. SCC offers also, through its infrastructure service, an easy iSCSI target setup mechanism where it relies on a one-click provisioning tool to support its deployment. You can review the section on storage for detailed configuration support and setup through SCC's manuals. Once the iSCSI service is a settable, bootable volume and is available through SCC's storage pool, allowing iSCSI initiators to utilize its fast deploy service. Compute systems with diskless drives can utilize these bootable volumes from its iSCSI pool and perform a boot from SAN operation, deploying their OS deployments in seconds. In Figure 4, it might be necessary for users to allocate a complete NVMe volume directly attached across a PCIe's switch architecture. Today, it is not required for a head node to be directly attached to a ruler. Instead, many pooled NVMe drives can be presented to many compute hosts across a PCIe switch fabric. Next series videos, we will step you through the management of Day 0, Day 1, and Day 2 operations of Supermicro's storage appliances.